Good morning. I hope you enjoyed that first video. Vi Hart was explaining logarithms and how it's just fancy multiplication. So we're going to talk in 8.3 about logarithms and logarithmic functions. So for the last two sections, you've been graphing and solving exponential equations. So you had something like y equals b to the x power, and you were graphing those and solving those. Well, there's an inverse to this guy because when you graphed it, it is a one-to-one function. So the inverse, remember to find inverses, you swap your x and your y, and you solve for y. Okay, so you've got something like x equals b to the y, and we need to solve for the y variable, and this is where logs come in handy. So, since we need to solve for the y, we're going to rewrite this in logarithmic form. B is called the base, y is your exponent, so that's your base, and this is your exponent. You can call this your power. X is your power if you like. And so we write it as log base, so subscript b, so that's what you're multiplying by. That's the power, right? That's our answer, if you will, is equal to your exponent. So this is a way to write this inverse so that you can solve for y. So this is called the logarithmic form. I can spell logarithmic form. Okay. So if you have to, for example, write the equation in, so we have exponential form, and we have logarithmic form. So we're going to do both. This is just practice to get familiar or get used to going from one to the other. So if you are given log base 4 of 16 equals 2, in exponential form, so right now you've got this form here, logarithmic form, we have to go to exponential. So your base is 4. Your exponent is 2, so that's equal to 16. So let's go the other way. Let's do 4 to the third equals 64. Write that in log form, logarithmic form. So log base 4, your base is 4, of 64 is equal to 3. So it's just going back and forth between exponential and log. Okay, and they go back and forth. Okay. Sometimes you're asked to evaluate. So this is where you would have an expression, not an equation. Evaluate log base 3 of 81. Okay, if you're going to evaluate this guy, I highly recommend that you write it in exponential form. So you have, let's say, equals y. So you have 3 to the something power equals 81. Now I know your calculator does have the log function, but it's not going to be the base that you usually want. The log on your calculator has a base of 10, and that's it. It doesn't do any other base other than 10. I'll show you how to get around that eventually. But for right now, we're going to rewrite it in exponential form. So 3 to the what power equals 81? And you just kind of have to work through it. So 3 to the first, no. 3 to the second is 9. Oh, hey, if 3 to the second is 9, then it's going to be 3 to the fourth. So y equals 4. That's how you solve those guys. What if you have a fraction as your base? So what if you have, we're going to evaluate log base 1/2 of 256. We have to evaluate that. So I'm going to do equals y, so 1/2 to the y power equals 256. All right, a little bit of a head scratcher, because I don't know, really, it's 1/2 squared is a 4th, right? So this tells me I need to get this 2 back up to the numerator. So it'll be 2 to the negative y power equals 256, right? All right, so 2 to the what power will give me 256? Well, if it was 2 to the 8th, I would have 256. So y equals -8. All right. All right, let's talk about graphing these guys. It's not too bad because it's just a continuation of graphing the inverses. So remember that you had y equals b to the x, and that graphed like so. Now we're going to do the inverse. Now the inverse is just a reflection over the line y equals x. So we're going to reflect this guy over, which is kind of weird, right? And if we reflect him over, we're going to have something like that. Okay. Actually, I shouldn't go. Well. So we've got like so. There we go. Because this guy here, your y equals b to the x, this will never cross the x-axis. This is y equals log base b of x. And so that guy will never, I'm going to make this go up a little bit higher. This guy will never cross the y-axis. Okay, so where do we touch? Like, where does it hit things? So if we take a look, we know that this point right here is going to be 1, 0. Let's think about that. If x is 1, that's y equals log base b of 1. Or b to the what power equals 1, 0. So that's why it's going to always go through 1, 0. Okay, what about if we have a base, let's say x is 1. So if x is 1, we'll have y equals log base b of 1. So b to the what power equals 1. I just did that. That was dumb. Just kidding. I meant the other way around. 1 equals log base b of x. Sorry about that. So b to the x power equals b to the first power, equals x. Anything to the first power is itself. So we will be at the point b comma 1. So if I'm up here 1, I'm going to be over here b comma 1. Whatever b is. All right. What about -1? -1 equals log base b of x. So now I've got b to the -1 power equals x. So x equals 1 over b. So if I go, my coordinate would be 1 over b comma -1. So 1 over b is going to be down here and down at -1. So 1 over b comma -1. So those 3 points will kind of give you enough information to be able to graph. So let's try them out. All right, so we're going to graph log f of x equals log base 2 of x. Not too bad. And we're going to use, our b is equal to 2 in this case. So if I draw a little table, my x coordinates will be 2, 1, and a half. Sorry. our y coordinates. Well, when x is 2, that means that we'll be at 2, 1. When x is 1, that means we're at 1, 0. And when x is a half, we're at -1. So to graph this guy, over 2, up 1, over 1, up 0, and over a half, down -1. So it'll look like that. Not too bad, I don't think. Let's try another one. Let's do some transformations. So let's take a look at y equals a log base b of x minus h plus k. So it's the same old thing we've been doing all along. Here we go. Let's do, let's see. Let's do this one. We're going to graph f of x equals 2 log base 3 of x minus 2. All right, let's start off with our chart for just log base 3 of x. Let's just do that one, okay? And then we'll change it. So x, we said, let's let x be the values we chose last time. So let's do, sorry, I lost my piece of paper, it blew away. The refrigerator. Okay, so let's do the values of b, so 3, we'll do 1, and we'll do 1/3. And so when b is 3, y is 1. When b is 1, y is 0. When b is 1/3, y is -1. All right, so then let's change it up. And now we're doing 2